So good evening, guys. We are here on the presentation or just to demo the project I've been working on, which is Dirty by Vulnerability with CVE-2022-0847, which is called the Local Privilege Escalation in Linux kernel 5.8 and above. So we have run the reports, set up the lab environment, and we are going to be reproducing the vulnerability. So this is a critical vulnerability in the Linux, and it was disclosed by Max Kellerman in March 2022. And although the most recent version of Linux, they have patched this environment, but it is good for the cybersecurity to be able to explore this and red teams so that they can, for research purposes, and to be able to know how to protect it. So why is this vulnerability dangerous? It's dangerous because you can use a standard account with, to escalate your privilege to root and make changes on the read-only files. So and this the root cause is the improper use of pipe underscore buff underscore flag underscore canon underscore home match. So we are going to be seeing that in action during this presentation at the lab. So what is the real world implication? With this exploitation on vulnerability, attacker can replace the sudo or etc the password and be able to make changes into file within a Linux environment. And they can also escalate the privilege in Docker or LXC containers. All right, so for now, I think the only mitigation is for you to patch your environment, or yes, so you'll be able to get rid of this vulnerability. So without much ado, I will hand over to my colleague for him to continue with the lab. Over to you, John.
Okay, so now we have already executed inside the container. So the container is running on the vulnerable Linux kernel, and because we're running in the VM, which is also vulnerable to the dirty pipe attack. So when we do the nab in the Docker container, the container is using the host VM's kernel version. So this will guarantee that we are able to reproduce this CVE. So I'm inside the container. We have what's wrong, John? You need log in.
Okay, it's the same password I gave to you. All right, go ahead.
Okay. So in this container, we have a C program, and we got this program from online, but we updated it to make it work in our environment. Let me quickly walk you through this program. So basically what it does, it will write the frame into the pipe, and which will override. It will overflow when the frame got linked through the piping. So the things we can check is the password in the etc password file will be copied into a temp folder, and then the password will be updated, and a new root password will be inserted as array. So this means after we run this program, we are able to sue into the root user with the password array. So let me run the program. And then we use suroot. We type password array, and you can see we have become a root user. And to double check, we can compare the original password and the updated one. So I will first check the password in the temp file. As you can see, this is the original password, and I will check the updated one, which is in etc. Type error. So as you can see, the password error was inserted into this file. That's the reason we're able to sue into the root user with this password. So this confirms that the read-only file password has been updated by the data pipeline, and it will conclude this snap. So
Thank you very much.
Humberto.
I will hand over to Humberto, who's going to conclude this presentation.
Yeah, for the MITRE mapping, we mapped all the issues related. I mean, possibly all the issues related to this dirty pipe. And not only those that the tools would give us. For example, if you try to use the MITRE mapping tool, it will only give you the privilege escalation techniques related to this specific attack. And the reason behind it is because of what John just showed us. It is specifically a privilege escalation type of attack. But we thought of stepping back and analyzing from the very beginning. For example, John showed you guys that this needs a local account, right, to be performed, because he was already within the system, within the network, he had access. So that's why he could perform this attack. So, and for this, we have a few techniques by MITRE. And the techniques are found on TA0001. And specifically, we mapped two techniques, 1078, which is a valid account, and as well as 1566, which is phishing. And why did we map that? It's because the valid account has a local account technique. So for the network administrator or for cybersecurity folks, we need to make sure that we manage these local accounts very closely. As well as the 1566 is about phishing. So making sure that the employees do not compromise any machine and no outsider accounts can be created. We also map the sub techniques, but I will just go over the techniques here to be brief. Secondly, we also mapped execution, which is under TA0002. Execution has the command and scripting interpreter. As John just showed you guys, it's very important to have control over what a user can do and user cannot do if a user does not need scripting. Regardless of the operating system, you can just disable it, right? Because that's not needed. So the attack cannot also be performed. And just one quick side note, we also mapped mitigation and detection. I will not go over them all because that would be too many. But all in all, it's about user training, user account management, multi-factor authentication, account user policies, and as well as disabling services. Detection techniques were also mapped on our MITRE mapping. The third is the persistence TA0003. This is the third tactic. The techniques under it are first 1136, which is create account. And then we have the 1554, which is compromise host software binary. So this is important because if a root level attacker adds a new root user once the attacker is already in, we can be aware of it. We can know that something is wrong because there shouldn't be two root users in the machine. While overriding SUID binaries falls under host binary compromise as well. So we could also respond to the attack. Going to the most important one, privilege escalation tactic. The technique is the number 1068, which has no sub-techniques, by the way. This is the exploitation for privilege escalation. That's the most important one. We have mitigation strategies for that, which is OS configuration, execution prevention, exploit protection, and the one Florenzo mentioned before, updating or patching the OS. And the attacker exploits the dirty pipe to overwrite the password. That's the use case that was found. So, or similar critical files, enabling privilege escalation by injecting a root level user or modifying credentials as well. And under it, we also mapped the techniques 1098 account manipulation, which is also under privilege escalation, and the sub-technique additional local or domain groups, which means we don't want the attacker to be creating even more accounts under malicious attack. And then we also map defense evasion to make sure once the attacker is already in, we still can find it, right? So under TA0005, we have the 1070 indicator removal, and then we are looking for specific files. For example, if the attacker tries to delete a log file, we can capture it. Because if files that should not be deleted are deleted, we can capture it. The other thing is hidden artifacts. As it was showed, the attacker can create artifacts that are not expected, such as backdoors in the system. Last but not least, credential access was mapped under TA0006. And this TA is about credential dumping. Let's say John just got the root user superpower and then wants to, dump some more passwords, wants to dump some more important files. So if we monitor it, we have a chance to also avoid this issue, although the attack was successfully performed. And these were a brief about the tactics and techniques from MITRE that we mapped for this attack.
Thank you very much, Humberto. And this signifies the end of our lab and reproducing the vulnerability and Linux environments. Thank you very much.
Thank you.
Bye-bye.